Here we go. I know what you were doing. You forced a square root into it, but at the bottom of it all, it really doesn't matter. It'll take care of itself. So I've got an a squared plus u squared situation. If you factored it the way the guy gave it to you, yours looks like 2 plus x squared. I like my x's in the front, but it's equivalent. So if a squared is 2, a is the square root of 2, u squared would be x squared. So I'm going to let u, which is x, equal a tan theta. I need an expression for dx. The derivative of a square root of 2 tangent would be square root of 2 secant squared theta d theta. And then I was messing around to see what this bottom would clean up to be. So in for the x, I had to square that, so that made 2 tangent squared, and then the plus 2 that was there, factored a 2 out, tangent squared plus 1 is a secant squared, but really that whole thing is squared, so that cleaned up to 4 secant to the 4th theta.
So you don't need a square root in the bottom to do the...
Well, there really is one. If you think of it as a square root of something to the 4th power, that's what she, because this is really to the 1/2 times 4, which makes it to the square. I just did it as a square. As long as the exponent works out, it doesn't have to be written as a radical. And then you need an expression for, you have to put something in for dx. So in place of that dx, we have square root of 2 secant squared theta d theta. Now, I haven't done any integration yet. All I've done so far is a bunch of trig substitution. So let's see where you can go from there. Did you get this far? So then you brought out the coefficient. So out in front, we've got a square root of 2 over 4. And a secant squared over a secant to the 4th is 1 over a secant squared. Oh, how cute is this? But 1 over a secant squared is a cosine squared. This was similar to the test question. If the power on the trig function is even, you need to do a power reducing formula. So I'm going to cut this out and try to put it on the next page. So let me see, that's square root of 2 over 4. This is 1 plus cosine 2 theta all over 2 d theta. I think the one on the test was a sine squared. So that one's a 1 minus cosine 2 times the angle. This you can split into 2 integrals. So we've got square root of 2 over 4. I'm just going to make a big bracket like that. And I've got a square root of 1/2 d theta plus a 1/2 integral cosine 2 theta d theta. That piece is a, how about a theta? That'll turn out to be a 1/2 theta. To integrate this, yeah, the u is 2 theta, so you're going to need a 2 d theta. So you're going to have to do a 2 on the inside here. I don't know where to put it. It needs a 2 in here, which means another 1/2 out there. So now I have square root of 2 over 4 times 1/2 theta plus 1/4 can't draw a right triangle with 2 theta. You have to know your old trig identities, that double angle formula. Sine 2 theta equals
2 sine
2 sine theta cosine theta. So this piece becomes square root of 2 over 16, 2 sine theta cosine theta. Good old trig class. This piece with the theta, you can't really do anything with, but I'll show you what the cute trick is. So let me go back to the beginning of the problem. We let x equal square root of 2 tangent theta. X equals square root of 2 tan theta. And in the little list of rules I gave you, it says solve for the trig function. So you would divide both sides by square root of 2. So we have x over square root of 2 is tangent theta. Tangent is opposite over adjacent. So you can now draw a little right triangle. There's your theta. The x has got to go there. Square root of 2 has got to go there. C equals the square root of x squared plus 2. The theta is going to come from this statement right here. If you need, yes, somebody said it. If you need to solve this for theta, you have to take arctan here and arctan there. So what we get is arctan of x over square root of 2 is the arctan of a tan, and the inverse of the function just brings you to the theta. So that's what's going to go in the front for that square root of 2 over 8. That's pretty mean all by itself. Oh, yeah, let's stay there. Come on. So I have square root of 2 over 8 arctan x over square root of 2, square root of 2 over 16 times, oh, let's do this. All right, so sine would be what over what? Yeah, sine is opposite over hypotenuse. So the opposite side is x. The hypotenuse is the square root of x squared plus 2. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So that's the square root of 2 over square root of x squared plus 2. Oh, so a little bit of cleaning. Square root of 2 times the square root of 2 is 2. 2/8 we can turn into 1/4. And a radical times itself? Just itself. So let's see. I can't fit this back in again, but let me just put a new piece of this. This ended up being 1/4 x over, thank you, x squared plus 2. So that at least cleaned up to, oh, plus a c. Now that's a Calc 2 problem. That's got everything in the world. Double angle formula, inverse trig functions, power reducing formula, old reciprocal properties for trig functions. Look at it all. I know, that's a killer problem. But at least it was 39. It was a little further down in the set, you know. It was the last one in the set? Okay. So that was worthy of the last problem in the set. Yeah.
I just noticed the guy on Calc chat, he does a little different, like the substitution part at the beginning. Like he manipulates u equals a tan theta, for example, to get a piece that you already have in the function, and you don't have to actually like do the way that.
Yeah, actually, we were just talking about that. He has you kind of memorize what the different formats turn into. I always have to make my substitution and use my old trig identities. This piece right here, he would jump from that part, I think, right on down to that part. But I have to see the two being factored out.
Well, what he does is, I mean, what I figured he was doing was, I mean, he does a right triangle in the beginning and he solves all the parts, and then you had as your hypotenuse, what's x squared plus 2 was your hypotenuse, which is what you have in the problem. So he solves for x squared plus 2, which would equal which when you like use secant of the problem, so you have the x squared, and then he solves it for, and then he just plugs it in what he got, that x squared plus 2 was equal to.
How did you decide that that was the hypotenuse?
Okay, like you got your, like you did your a equals u tan theta, right?
Oh, so he does do that
Yeah,
stuff. Okay, so he did say that he had to let x equal square root of 2 tangent theta.
Yeah, and then you do your actual triangle.
And then he did the little triangle from this. So he's got basically the same picture. Tangent is opposite over adjacent, and that made this that.
X squared plus. And then if you use like your secant, you know, you would have secant theta equals x squared of 2 over the radical 2, and then like if you solve for secant theta, I mean you solve for x squared plus 2, so you can just plug it back in what x squared plus 2 equals.
Can't think like that. I'm sorry. But if you can, you're welcome to it.
Well, it was like I saw he did that, and I figured it was easy to manipulate that way.